Now, this is problem 6, and we have some mole-to-mole conversions. Most of these we're converting from moles of a compound to moles of an atom. And for that, we use something called subscripts. Okay, you want to use the subscripts. That's the 6, the 14, in this formula. All right, so let's see how this works. We have moles of carbon and then moles of this formula. So we first want to write out an equivalency. 1 mole of C6H14O is equal to 6 moles of carbon. Okay, and we're looking at that 6 here in the chemical formula. And when we write out the conversion, we start out with the given quantity. We have 0.185 moles of this formula. And we want to place things about this fraction bar for the units to cancel. The 1 mole is going to be on the bottom of this chemical, C6H14O, and that leaves us with 6 moles on the other side of the fraction. Okay, so the moles of this compound will cancel, and we'll be left with moles of the atom. Let's multiply this out on our calculator, round it to 3 sig figs, and we get 1.11 mole of carbon. Let's do B. For B, we are dealing with the same chemical, but we're looking for oxygen. So 1 mole of C6H14O. Now, what's the subscript for oxygen? Well, if it's not indicated, it's assumed to be 1. So there's 1 mole of oxygen in this huge molecule. And so when we do the dimensional analysis, once again, we start off with the given quantity. Okay, C6H14O. And we set up our fraction bar. And on the bottom of this fraction, we want there to be 1 mole of C6H14O. All right, and that's going to cause that to cancel. And on the other side of the fraction, we're going to have 1 mole of oxygen. And you can see how we're not going to grab our calculator to do this, but the calculator can only work with numbers. We can work with units, and the whole point in us doing this is to make sure that the units are canceling and converting from one to another. Okay, so that's the answer. It's the same quantity, just different units. How about for C? We're interested in hydrogen. Now we have this crazy formula, C6H14O, and there's a subscript of 14 for the hydrogen. Okay, that's huge. It's a big number, right? So there's 14 moles of H per 1 mole of that. And we set up our dimensional analysis with the starting units here on the left, moles of C6H14O. And we set up our fraction bar, and we try to make the units cancel. So 1 mole of the compound is going to be on the bottom of the fraction bar. Okay, and on top we're going to have 14 moles of hydrogen. Okay, so let's cancel out those. And grab your calculator again and type in 0.185 times 14. And we want to round this obviously to 3 sig figs, and our calculator just shows us 3, so that's great. 2.59 moles. Which element? Hydrogen. Okay. Now, in part D, we want atoms, okay? Not moles, atoms. So how do we do this? Well, we start with moles and we somehow convert to atoms. So for part D, we know we have 1.11 moles of carbon, and I somehow need to convert that to atoms of carbon. So the key thing to remember here is that 1 mole of carbon is equal to the Avogadro number atoms of carbon. Okay? So when you set up the work, you're going to start on the left with the given units given here from part A. And we set up our fraction bar as usual. Okay? And on bottom, we want the 1 mole of carbon to be there. Okay, so that the carbon cancels. And on top of this fraction, we want there to be Avogadro's number. Okay, and here you'll grab your calculator and punch this in. And you'll get 6.68 times 10 to the 23. Okay, and we want to write the units atoms of carbon. Okay, so thanks for watching. Please subscribe.